Thank you for joining the October 11th, 2018 VOLTA call. We have a few items on our agenda today for discussion. Do keep in mind that we post this to YouTube after the meeting, so keep that in mind during discussions and any presentations as well. So the items we have for today's discussion, we had a request from the Foundry side for a discussion on BBSIM with Keita-san. And I think I saw Keita-san on here. Yes, I do.
Yes, I'm
and
here.
then Matt, I see you on also. Do we have others in the room with you from the Foundry, or are we on different lines today? Oh, it looks like he just got connected to audio, so I'll have to state that again in a moment. Okay, so we'll have the BBSIM discussion, and then Sean Missette will give some updates on the tech profile proposal. And then with any remaining time, we'll be looking at doing 2.0 sprint planning. In particular, since Sprint 9, which kicks off next week, is the last planned development sprint for 2.0. So we need to take a look at what needs to be prioritized and what's achievable in this last development sprint. And with that, Matt, I think I saw you connected on the audio. Do you have other Foundry folks in the room with you, or is it going to be on different lines today?
It's just me right now.
Just
I think
you. Okay.
I think that may be it. Yeah.
Okay. So I think Don had been the one who brought up the request for the discussion. Do you have other?
I can speak to it.
Okay.
I guess really it's kind of just an open discussion. The motivation is we're getting to the point now where we'll start doing some sort of load testing, stress testing. And with the new way we're doing OpenOMCI and actually having an OMCI-based message exchange with the ONU to determine how to configure services, we will need BBSIM, and I know Keita-san has already started working on this. Need BBSIM to actually have the ability to answer back and conversate in an OMCI fashion.
I also want to, discuss about that today.
Okay.
Can I share my screen, because I have material for discussion.
Great. Let me
Sure.
give you presentation rights.
Yes.
And you should have them in a moment.
Can you see my screen?
Yes, I can. Thanks.
Okay. Okay. Can I explain the architecture of BBSIM today, or is there no time to do it?
I think we have time. We have an hour and a half today, so we have plenty of time for this discussion. I think that would be
Okay.
nice.
Okay. It takes just 10 minutes or 15 minutes. Okay. So let me explain the basic BBSIM architecture. Because I changed the basic architecture last month for containerization. BBSIM acts as if a single OLT with multiple ONUs. BBSIM container contains BBSIM process and WPS applicant and DHCP clients. Each container corresponds to a single OLT. And this container connects to VOLTHA and ONOS via adapter, and it runs. Please note that currently BBSIM uses BBSIM unique adapter and Broadcom ONU instead of OpenOLT adapter and Broadcom OpenOMCA adapter. I will explain the reason why later in this presentation. Next, I would like to explain the current achievement in BBSIM. Currently, BBSIM succeeds to emulate multiple OLT and ONUs and DHCP AAA emulations and containerization in order to make the deployment easier than the previous. And I will show you the emulation of BBSIM using ONOS GUI. So this GUI view in ONOS shows that the BBSIM successfully emulates the single OLT and 16 ONUs that are connected to the OLT. And more than that, you can see that, oh, just a moment. I want to make the text bigger. From the viewpoint, from the CLI view of ONOS, you can see the all ONUs are authorized by AAA application running on ONOS, and IP addresses are successfully assigned to each ONUs using the DHCP L2 relay application running on ONOS, like this. Okay. Okay, then, these are the discussion items. I'm now planning to develop some features to improve BBSIM quality. For example, LLDP packet support and OpenMCI support. LLDP packet support enables the ONOS to show the connection between BBSIM and the AGG switch that is located to the upper of BBSIM. This would be useful for demonstration, I guess. And yes, this is the main discussion point today, I guess. OpenMCI support. So BBSIM currently does not support OpenMCI response. That is why the BBSIM uses Broadcom ONU adapter and BBSIM adapter instead of Broadcom OpenMCI adapter and OpenOLT adapter, which requires OMCI response for creating a logical device in VOLTHA. BBSIM is written with Go language, then it is necessary to implement OpenMCI stack from scratch if you want to use OpenMCI in BBSIM. However, unfortunately, I don't have enough resource to develop that. So I need the support from community if you need OpenMCI emulation in BBSIM. Yeah, that's all of my presentation today. Thanks. Do you have any? Does anyone have a comment or question?
Yeah, I was curious on the screen where it was running. Do you have like a VOLTHA CLI running, and could you just run devices there? I'm just kind of curious to see what it looks like.
Thanks.
So you showed the ONO CLI. I'm curious just what the VOLTHA CLI looks like.
Okay, just a moment.
Okay. Other than that, just in general regarding OMCI support, really what this means is supporting an interactive OMCI conversation. The Broadcom OpenOMCI adapter, as part of using the OpenOMCI library, goes through a MIB discovery phase where it discovers what TCONs are available, PPTPs are available, things like that, and then uses those values to then provision services. So that's kind of catch, is we need to have a way of, if not actually having a device to query, at least simulating maybe the answers for certain MIB entries like PPTPs or TCONs or ANIs or things like that.
Yes. However, okay.
I can speak a little bit to that. There's a couple of possibilities in the OpenOMCI. All the as everything is done, it's actually performed by a specific task that do the OMCI conversation. So you can actually write, provide your own task that actually just provides you the response that you need. So you are actually not even doing any OMCI to the actual device. So you can actually bypass the entire sequence and probably preset what you want. So that's one way to use the existing implementation.
Would that require creating a new adapter or an overrided adapter?
I'll probably do an overrided adapter. So pretty much like what we do for the OMCI capabilities on a couple of ONUs. It doesn't actually query the OMCI ME entry. It actually provides the answer, just when first asked. So I think that would be one thing. We just would need to make sure that all the service provisioning is also faked as well. It's done by task, and I've actually converted on the Adtran one. I've already converted those all over to task. And then the second thing would be I'm actually, just as a personal private project, I'm going through and writing an ONU mock out of Golang that should be able to act like pretty much any actual ONU and talk to an existing ONU device adapter.
Mm-hmm.
But I've got the infrastructure for that done, and currently right now I'm writing a parser to try to code generate a lot of the ME library, because the biggest headache in OMCI is parsing all those crazy ME frames.
Yes. So could you tell me the name of the project you're now developing?
It's over in my GitHub library.
Okay, I will check it.
Yeah, I think it's called ONU mock.
Mm-hmm.
And I've initially got it set up, but right now I'm focusing on parsing the ITU 9.88 document to auto-generate the majority of the MEs, because I just don't want to code those by hand.
Chip, I couldn't get the meaning of bypass that you mentioned. So could you tell me again?
Yes.
Yeah, put it in the chat window. That'll work.
Yeah, there's some pages up on the OpenOMCI wiki documentation under design on how the OMCI is performed as a series of tasks that do specific steps. And there's an example in there of how to override like a specific task to do your own steps. So for instance, if you want to do like the MIB upload initially, you can just basically rewrite that task, and the main idea behind that task is to see the database. You could just hard code that to see the database, and it looks like
yes, exactly.
But we can talk offline, so we don't.
Okay.
Unless everyone else is interested.
I'm sure people are interested. Maybe.
Okay, yeah. Well, basically, there's in OpenOMCI, it's written so that individual whole state machines or small portions of a state machine can, like for bib upload or alarm synchronization, can be overloaded, and then most of the actual tasks to go out and use the OpenOMCI, the OMCI communications channel to, upload a MIB or provision MEs, you write that as a task that is submitted to the channel to run. So they have some very well-defined syntaxes of what they do, and they provide either see the database or actually provide a number response like back to the caller. All you'd have to do is an ONU adapter is provide your own task that provides the answer for you without actually doing the OMCI communication. Sort of like a cheat sheet.
So I guess in the case of like the MIB synchronization state machine and set of tasks, just kind of override your own and basically just turn around the answer we want for the simulator.
Yeah. So for the for the MIB synchronization, what I would do is provide MIB upload, fake that out, and then set the variable in your MIB synchronizer so it never performs an audit, and it looks like it comes up and stays in sync forever.
And Chip, I think one of the issue that Keira-san brought up is, the BBSIM is written in Go, right? So
Yes.
And then some of the stuff. So what I'm saying is that your personal project, you're putting on Go stuff. Is that something you can share with Keita-san? So give him some start on that one.
Oh, sure. It's out in the public right now. It's mainly oriented so you tie it into the OLT adapter, so where it performs the proxy message, it just does the gRPC into the mock.
That is written by Golang, right?
Yeah, it's written in Golang mainly because I wanted to be able to have it scale to many thousands of ONUs or until your CPU dies.
Yeah, I knew about that last time when you were in Atlanta. You told me. So that's great.
But it still has some work to do, but it's coming along nicely.
Okay,
I guess there would be two elements, right? There would be the actual creating the overrided adapter, which would be a Python override. So it'd be creating the state machine and the tasks at using the set of classes that exist in Python. But then the actual simulating of an OLT, the simulating of an ONU would be in Golang, providing either limited or no answers in this case, just facilitating the traffic when the time comes to actually pass traffic. Is that?
Yeah, that's correct. Yeah, the way I would go is to write a overrided Python adapter and get that working, because that makes you come up and it looks like you're running. And then in the ONU mock, what I have is I'm trying to work on it so we can do fault injection, and so we can simulate ponds going down or an ONU rebooting, at scale, just to see how the OpenCI stack handles things. But that would be future. Does that make sense?
Yes, I will check out the source code which you developed, and I'd like to discuss about that later. Is it okay?
Okay, that'd be fine. Yeah, I'm available.
And if you could also just drop a link in either the chat window or somewhere, just with the path to your repo where that is, that would be helpful.
Okay, yeah, that's a smart idea. I'll do that.
Cool. Okay. Well, I don't have anything more to discuss. This looks really good, but yeah, it makes more sense to me now as well.
Would that be too public if you just post on the VOLTHA Discuss on that link?
Yeah, I guess so. It's a work in progress, so I'll provide it over the.
Thanks, Chip.
Yeah.
So no warranty expressed or implied, standard procedure.
Yeah,
Right.
no promise. I mean, we'll see what usually I get a lot of work done during Christmas, so.
Well, Christmas will be after 2.0 release, though. Well, I can always ask, right? So.
Yeah. Well, frame parsing is going to be the biggest headache that I'm tackling right now.
What? Okay. Well, anyway. Okay.
Yeah.
Thanks.
So Keita-san, thank you for the presentation. Oh, it looks like you gave me presentation, or you are giving me presentations. I'll take that back here. And
I have a quick question. Sorry, Julie.
Yeah.
Is there any performance test that has been conducted with the BBSIM and VOLTHA core and the entire thing, or is it just like a simple create device stuff like that have been done? Like, is there any formal performance tests that are already been conducted with it?
Not yet. So
Okay.
I'm trying to conduct some scalability tests using BBSIM for ONOS and VOLTHA, but it is just the personal ones, and it is the formal scalability test has not been conducted. So I'm now trying to introduce BBSIM to SIBA architecture. Then after that I will conduct some scalability tests. Does it make sense?
Okay, thank you. The reason why I'm asking is in VOLTHA 1.x, there is an adapter called simulated OLT and simulated ONU. We have been using that to do performance testing before.
Oh, right.
And in 2.x, if there's a way to get BBSIM for performance testing, then I would prefer to have BBSIM into adapters for 2.0 instead of having to port the simulated OLT and simulated ONU into adapters. So if there's a way to do that, then that's that will work better for us.
Okay. Yes. Now the BBSIM source code is uploaded on Gerrit and GitHub. Then it can be used. I believe it is useful both for 1.x and 2.0 in the future.
Okay.
And,
okay, thanks.
We did talk about one time about the difference between the BBS. So Ken, you're talking about PoundSim, right?
No, not PoundSim. There is a simulated OLT and simulated ONU in VOLTHA. And when we conducted like any performance testing, for example, we'll go and do a lot of crate devices. So the simulated OLT will just return us, oh yeah, sure, I have a device. So that will just load the core, but it's just like there's no, after the simulated OLT and ONUs, they have no connection to the external world. So it's really like testing the core. So if we want to have an end-to-end performance testing where we have an actual connection with an OLT, even if it's a simulated OLT, if we run the performance test in 1.x, and then after that we do that 2.0, when everything is going over Kafka to an adapter, then we'll be able to see the performance impact and improvement and everything. Otherwise, we'll have to take the simulated OLT and simulated ONU and build them into containers and then do the test again. So if the BBSIM can do that, then I'll prefer to not duplicate the effort.
So I think that the goal for BBSIM is definitely to build it enough to make it as a performance testing or capacity testing, right? So I think that's exactly the goal for BBSIM. But containerization of the BBSIM, that's additional work that the BBSIM will need to conduct once the 2.0 is introduced, right?
Yeah, it needs to, but looking at the BBSIM code, it looks like it's inherit from OpenOLT. So I guess OpenOLT needs to be containerized first.
That's right.
So OpenOLT has to containerize first. So there's a dependency on that one.
I understand.
I think yeah.
So we'll see how it goes. Like which one come when the time like 2.0 is ready for performance testing. We'll see if BBSIM is ready. If it's not, otherwise we'll just port one of those OLTs, simulated OLT into adapters and use that one.
So on the PON simulator and ONT simulator and the OLT simulator doesn't depend on any adapter. Is that correct?
Yes.
Yeah, they don't.
Okay.
Sorry, I want to make sure that so what adapter doesn't depend on the adapter? So could you tell me that again?
No, the simulated OLT and
I got it.
ONU, they are standalone by themselves.
I got it.
So they have no dependencies.
Thanks.
So okay, so for every ONU that's simulated, is there a corresponding subscriber record created?
Right. Yes.
Okay. So ONOS has all the subscriber configuration already. Okay.
Yes.
Is that automated, or is that basically in a file?
Unfortunately, I have to create status configuration for for registering the subscribers of each ONU.
Okay, so a predetermined set of serial numbers, etc. Okay.
Right. Yes.
One thing is, Matt, do you still want to Keita-san to show you the CLI command on the VOLTHA side?
Okay.
Yeah, I forgot about that. Sure, real quick, if you don't mind. I'm just curious what it looks like.
So what do you want to see in both CLI?
I guess just run devices, and then under the OLT device, run flows. That's mostly what I'm curious to see.
Okay, so Julie-san, can I show my screen?
Yes, let me give you presentation right.
Sorry about that. I forgot I asked.
No problem.
I also forgot that. So, just a moment. I want to make the text bigger again.
Yeah. Okay, cool.
Yes, you can see the simulated OLT and ONUs like this.
Okay. Yep.
Okay.
And then if you just go into the the OLT device, and then run flows and ports. I'm just curious. I don't want to take too much time.
Flows. Oops. Yes, the current BBSIM already doesn't support the flow add command. Then there's no flow inside BBSIM already.
Okay. But so from the ONOS's point of view, it did add flows. It went through OF agent. It's just when it makes its way to the BBSIM OLT adapter, it basically just says, I got it, and doesn't actually create the flow. That's what it seems like, right?
Yes. Oops.
But for the capacity testing, would the flow actually important?
Yes, I agree with that. Yes, from the viewpoint of ONOS, it adds some flows into BBSIM OLT, and the state is now becoming to added that it doesn't actually introduce to BBSIM OLT.
Yeah, so I'm saying is, so the adapter basically has a no-op there that says, yes, I've added it, but from the point of view of the simulator, it knows what it needs to do, but it doesn't actually add the flow. But from ONOS's point of view, it's there. Is what it looks like.
Yeah.
Okay. All right. And then I guess when subscriber flows get added, they would show in ONOS, obviously, but would they be in the same situation when the subscriber flows are pushed to the simulated ONU? It would be a similar kind of just a no-op, but from ONOS's point of view, they would be added, correct?
Yes, correct.
Okay. Okay.
Well,
All right.
How about from VOLTHA Core's perspective? Does that think there are flows?
VOLTHA Core?
Yeah.
Sorry,
Or is that a no-op as well? It looks
like
we
were just looking. VOLTHA Core doesn't show that it had any flows recorded.
Oh, sorry, I thought that was the adapter. Okay.
Oh, well, there was the OLT adapter. Yeah, we didn't look under any of the ONUs. But anyway, that's good enough for now. Thank you.
Yeah, thanks.
Okay, thank you.
If on the VOLTHA level is required, that it's important, then maybe we can open a JIRA on that one. Again, I think the purpose of BBSIM is for the performance and capacity testing.
Yes.
And I think the North Forge is you guys on here also. I think that's probably very potential. That's the stuff you can use. So, no, Keita-san, thank you for all the hard work. I think this development has a lot of potential. Again, I want to point out the OpenOLT adapter is the dependency here. We've been trying to align resource to help the OpenOLT adapter containerization. But I think definitely we need more help from the community to do that. Otherwise, we probably we'll have a big gap during the VOLTHA 2.0 timeframe for the OpenOLT. So I just want to bring this on the table. I think Saurav had the Shad has a presentation, something regarding to the OpenOLT branching. It was on the VOLTHA Discuss, but I think the Shad also have a presentation. So maybe Julie will probably do need to sometime to schedule that discussion.
Okay, So let me know when we need to do that.
I thought it's scheduled for next Tuesday.
Oh, yes, that one is, yes. Sorry.
It's already scheduled?
Yes, next Tuesday.
Okay. I cannot read.
It's early here still. Okay, our next topic today was looking at the tech profile proposal update. And I just had a question. I saw something in chat from Kirk. Were you needing to be presenter? That may have been a mistake. Okay. So
yeah, I'm sorry, Laurie.
Okay, no problem. Just checking. Didn't know if there was anything we needed to add in. Okay, so Sean, do you have a presentation you want me to give you presentation rights today, or verbal discussion?
Yeah. So I'll just display the document
okay.
I sent out.
So let me get you presentation rights. Okay, you should have it in a moment.
Do people see the
document?
Okay, all right. So this document, basically, I exported the technology profile management section from the wiki that David Bainbridge had put in there. I'd done a few subsequent updates, but so I basically modified that export in the Word document just to add in some more types of profiles. I just wanted to see if this, the community thinks that this might be useful. So basically, I kind of added a few different types here. So basically, flow, interface, play. I'll just call that equipment in the end. But so basically, flow is basically what exists currently. The technology profile that defines the in this case the XPON infrastructure for the service flow. It defines the TCON and scheduling and gem ports, etc. So what I added was some other examples of interface. For instance, if I wanted to define a profile for my PON interfaces, so in this example I'm showing here is there's a default profile for XPON that shows the ability to default downstream and upstream FEC and downstream and upstream AES, and also the mode that we want DBA to operate in. So this would allow for any particular type of technology, in this case XPON, to have a profile for how you want to set up the interface initially when you create it. And this may be overridden later on when if you have other configuration options, or you want to change some option here.
I do see the FEC and the AES. I think that's some of the requirement we were asking. But this list can grow, right?
Oh yeah, this was just my first pass. Obviously, it's up for change. And if anyone has any updates to what they'd like to see this default to be, then just you can either update the if we decide to go ahead with this, I can update the wiki, and then other people can come along and extend what the wiki has.
And so for example, if the operator want to disable the FEC, then we probably need the API from the northbound to enable that functionality, right?
Yeah, or depending on how this is implemented. I mean, if you disable an interface and associate a new profile, I don't know if that kind of operation would then take the new profile.
No, I think it's more like operational on-demand settings.
Yeah, yeah, sure. Yeah, if you want to have an interface that allows modification of the running config for that particular PON interface, then you can go and change that.
I mean, if we're going to create a set of profiles, I think there are any number of things that you would need, and there could be different operational models. One operational model that I would see would be that we don't want, we don't want this to be part of, subscriber provisioning from, OSS, BSS. We don't want this to be part of, oh, I got 100 meg service and I want FEC. I mean, we don't want to add a whole bunch of options onto creating a specific subscriber service. But there could be a specific subscriber that is having an issue that we want to put kind of a maintenance condition on. So we're going to go down to that specific port and put a maintenance condition on that person. So I would see that operationally one way to do this is operations will come in as they load the technology profiles and they assign them to different types of service types. This is my residential profile. This is my business profile. This is my whatever technology profile. They would also put on these types of interface profiles that these are my base level configurations that I'm going to operate in my network, and here is the base set of profiles that we're going to use, and I'm going to tell the system, I'm going to tell VOLTHA, anytime you have to use XPON or whatever, these are the interface profiles, these are the different types of profiles and the things, this is what I want to have. And then I would see that they would potentially also have the ability to create, okay, here's a maintenance profile. These are the maintenance activities that I normally do. And so then you would need the mechanism, as Sean says, to come down and say, on this interface, use the maintenance profile. And that doesn't affect anybody else. It just says, on this particular interface, use the maintenance profile. I don't know that we want to get down to let individual control of every single little thing that might be on the PON come down and get to the point where we're like trying to expose a full upstream Yang model of everything that you could possibly do on a PON. I think it would be more kind of, as an operator, you learn the maintenance activities that you want to use, and you then go develop those maintenance profiles and push the maintenance profiles down to achieve whatever actions you want to do. And if in your particular case as an operator you say, I never want to use FEC, then simply your default profile is, I never turn FEC on or whatever. So I definitely think this is we should not try to get this into kind of a service flow, kind of an ordering kind of type of activity, but more this is an operational type of activity that comes down and can have a set of defaults that basically VOLTHA already has, but exposing some level of configuration to those defaults with these types of profiles, and then having the ability to create alternate profiles that that can then be used to handle specific scenarios and specific conditions. I think it also might be good, as we're talking about all of this, to think about some level of versioning, and are we going to allow profiles to be versioned, or are we just going to allow new profiles to be created with the operator has to manage themselves, put a version string in the name of the profile or whatever? I think considering some level of versioning on profiles would be a good idea as well, and possibly the ability to fall back to a previous version if something goes wrong. So that's kind of a side thing that I just was stream of consciousness came off the top of my head. But
yeah. So just to address the version. So there is a version string in each profile currently. like in the technology profiles for flows, right now there's a version string.
Okay.
I mean, that may become part of the name. I don't know. It could be. But right now there's a version inside every profile, and so I mean
that's up to the operator to assign that I am assigning version so and so versus automatically maintained by the system itself, or if I do an edit, I bump a version or something like that. So it's just a string that's assigned by whoever created the profile.
That's right. Yeah, I mean, so basically, I mean, the model that we're using right now for flow technology profiles is that basically the OLT adapter takes the profile that's referenced in the flow and creates an instance of that profile. And as part of the instance, it has the specifics around ALAC ID and Gemport ID, right? So that instance is separate from the base profile that is used to create the instance initially. So the profile sits in the system. It has that version. If someone could come along and change that, I don't think we're using the version right now, but in the future we could. And the same for this interface profile. It's basically, when I have this profile, it basically says what my initial PON configuration, my default PON configuration would look like. Because some parameters may require, to be set on initialization, and basically probably take a hardware reboot or something to go and change that, the implementation of that, like DBA, for instance. So the profile, it would be used on first creation, and it would be used to create an instance, and then from then on, normal provisioning would then apply.
Yeah, so I think, Sean, you might have answered this a little bit. So reapply the technology profile may involve with the flow to be removed and rebuilt. Is that a question? I have this question. Is that technology profile can be applied without reprovisioning the subscriber?
No, it's on when the flow is first created, the profile is used. After
so if I want to change that, I have to delete and then rebuild, right?
Yeah, so the model we were using, I think, was that basically you can't modify a profile. You have to basically delete the profile and add a new one if you want to change it.
Okay, and I think some of the discussion probably is more a profile management portion of the CBA discussion. Let's move on.
Okay, so that was one thing. So defaults for the PON interface. The other thing that we potentially may want to use, and if we do, is these equipment profiles. So let me just look at the ONU equipment one, since we're kind of discussing that a little bit. So this profile allows you to essentially configure things that that about a particular ONU type, some certain resources and capabilities that particular ONU might have. In this case, it's the match would be on basically the vendor and the type of ONU it is. And once you discover that, then you can say, okay, I want to use this profile to determine what capabilities the ONU has. So, for instance, listed here are the maximum of TCONs the ONU has, maximum of Gemports the ONU has. And basically, one of the things we were also discussing was the ranges of the TC layer attributes that that particular ONU has. So these are not discoverable from the ONU. You have to know those, like I say, priori. So this basically lists the ranges of those TC layer attributes that the ONU has. Also defines a number of slots and ports the ONU has. For instance, it may have one or more ANI ports. In this case, there's just one, and there may be some attributes we want to apply to that particular ANI port, for instance, again, an interface profile. So we may have an ANI default, like we were just discussing around the XPON default. An ANI default may configure things about that ANI interface. For instance, there may be an override for FEC. For instance, in general, the XPON interface may say, okay, FEC is enabled for every ONU. But once I get down to the ONU level, I may, for a particular ONU, I may override that to say, okay, FEC is disabled, depending on the usefulness of that. And then, since the Ethernet ports can be configured by OpenFlow, we may not have anything about the Ethernet ports, but there may be some ports that we may want to have configuration for. And so in this case, I'm saying okay, there's 5 uniports, and basically for each uniport, it basically just lists again the same thing, whether it's enabled or not, whether it's what a default profile might be if we wanted to apply a profile beyond what the STN controller would do. So that was pretty much the ONU equipment. Just the idea is just define some potential defaults and define some resource information that may not be available through, say, a MIB sync. So that was one thing for the ONU. Any comments on the usefulness of that?
Why don't you complete your presentation? I have some question I want to ask.
Okay.
Well, I think one of the questions that I would have is if we have all of these different sorts of spots that can change behavior, like turning off FEC for a certain ONU, then as we're retrieving, if we want to know how something is configured, we now kind of have to have a hierarchy of where did this configuration come from.
The actual running config would be in the instance information, right? So that basically, when I go,
I know, but you can look at the running config and you could say, okay, why is FEC disabled? I mean, you can see the config, you can see that it's disabled, and then you can go why. I go look at my profile and I go, nope, yeah, my profile, my instance profile says I have FEC enabled. Oh, but my ONT overrides it, and so my ONT has it. When you start to be able to configure things from multiple places, I don't know that that's a good idea.
Well, we already have that, right? I mean, I could configure something from a CLI, or I could configure it from an OSS, right? I mean, the OSS should always get notification when there's some kind of change in configuration, right? So that should be reported. But yes, so okay, I mean, it does add another level of indirection, I guess. This is the initialization of that piece of equipment or interface comes from a profile.
I guess I'm questioning putting configurations in multiple profiles. And then you have to say, well, which one got loaded first?
You mean the overriding of, say, FEC, for instance?
Yeah.
Yeah. Okay. I mean, we could say have a policy where we say, okay, there is no overriding of the interface profile, for instance, right?
I mean, if someone just isn't aware and they're sitting there and they're hammering against the profile and they're changing the wrong thing, trying to get FEC turned off or whatever, and the ONU is always overriding them because they're not thinking about the fact that it happens to be in the ONU profile. I'm just thinking of usage scenarios of.
Yeah, I think we just need to come up with a set of rules, right, that is applied across the board. And once we have our rules, then it should be pretty obvious what the model is. I mean, if there are no profiles, for instance, then there are going to be some hard-coded defaults for things. And as long as you know what those hard-coded defaults are in every case, then I guess you're okay. Okay, so I mean, okay, given that we obviously need to have some rules that are applied across the board, the other thing I had done was say, okay, if we have a OLT, we may want to have again, a profile that could be applied to a particular type of OLT. And again, there are some things, like a PON tag, PON ID, these are things that apply across the board to all the ports of an OLT. We also had some discussions around TCLA attribute allocation as well. We may want to define for this OLT what its limits are. And then once the OLT globally defined parameters are defined, then we can say, okay, per port, I may want to have some, again, a reference to a profile for that particular port on the OLT, that type of OLT. I may want to override TCL attributes on a per port basis. Define whether it's, the admin state is enabled or not, unlocked or not. So, I mean, that's basically what the profile for the OLT might look like. And this was just what I was thinking. So again, it's the same thing. Do we want to have profiles for equipment that would be applied based on a match of the type of equipment? So all the, this defines what the initialization would be for that particular piece of equipment. And some things, obviously are not available from the equipment directly, like the, ranges that would be applied for the TCLA attributes. So that's pretty much it, I guess. I mean, that's so basically adding interface profiles and equipment profiles is basically what this talks about.
So this document right now is on the wiki site?
No, I didn't modify the wiki at all. I basically just exported the technology profile management section out to a Word document, and I edited the Word document, which is this document here.
And it was over VOLTHA Discuss, Sean.
Okay.
Hey, Sean, this is Shad.
Yeah. Oh. Don't M.
So, yeah, I have kind of a uncomfortable, funny feeling about the profiles. I can't really place my finger on it. But the way I view it is like VOLTHA exposes a northbound gRPC interface, and something outside, may have these profiles or Yang models or something outside of VOLTHA has its models, and they could be Yang models or profiles or SNMP or whatever. And VOLTHA core exposes a northbound gRPC interface, so it provides the handles, it provides the entry points to configure things, and the interface could be a gRPC configuration. It's VOLTHA core is exposing certain APIs to configure this equivalent of this thing over here. So how would that? I mean, why wouldn't we go that route?
Okay, so what? Yeah,
as gRPC northbound interfaces.
Yeah, understood. I mean, so what? I mean, the position we're kind of in now with OpenOLT is that what we're doing is we're exposing the capabilities of different hardware physical OLTs, right? So we're exposing some capabilities there. Normally, those capabilities are hidden; that they're not part of any Yang model, right? So this profile, for instance, of the TCLA attributes, that's something that is never really managed externally. So WT385 exposed a little bit of that, but we ran into problems in that, if I want to centrally manage those physical OLT attributes that are different from OLT to OLT, then it becomes very complicated, right? Oops. And so, oh man. So I guess so. I guess if we want to expose these, physical OLT vendor specific attributes, do we want to do that? I'm getting a lot of email here. Do we want to do that by adding? Yeah.
Sorry.
Do we want to do that by adding, new Yang models, or is it something that, say, this resource manager that we're talking about can handle? Jeez.
Do you want me to take back presentation rights?
Yeah, go ahead.
Okay.
Well, let me just shut that down. Yeah. So yeah. So I mean, we could expose these things, but it's going to be, yeah. I guess is it something that we want to standardize?
Yeah, I'm not necessarily talking about implementing a what was that, BBF or whatever, Yang model on the northbound. But as somebody mentioned, I think Mike Garcia mentioned, is maybe the operator is really interested in a few key configurations, and we start by exposing those things as being configurable from the northbound gRPC. Now that's a different question, as the fact that our core, we want a core to be agnostic of technology. So so the core would have to pass this down in opaque fashion to the adapters. But I just, the fact that VOLTHA has a single northbound interface, which is gRPC, and it has a very clear, well-defined protobuf, and now that's going to change over to Kafka. I'm sorry. So that's going to remain in 2.0, and it's conceptually clean to visualize VOLTHA as having a single northbound interface, and profiles are introducing multiple kind of northbound interfaces to VOLTHA, and that's just my concern. So I think it's more.
We already have that, though, right?
And we can take it offline. I just wanted to comment.
Yeah, but we already have that because of the technology profiles for flows, right? So this basically, the profiles in general allow the creation of these files that define technology-specific attributes, opaque to the VOLTHA core, right? Because only the adapters go and get these profiles. But yeah, I understand the concerns that multiple ways for configuring things. So yeah, so this was again just augmenting what we have for the technology profile flows, right? So it allows, again, a similar transparent opaque file that only adapters would use, that gives them technologies and adapter specific information.
Yeah, that's okay. I mean, if nobody else in the community has a concern about the profiles, I mean, it's probably just me who's
I do think we probably do need to look deeper about with all these profiles and what's the impact. if it is just interface or, and then the management portion of the profile is above VOLTA, right? So, and I do need to, we do need to draw a line, what is impacting VOLTA or what is above the VOLTA's level, right? So I do have the concern, and I think we are, definitely device management portion is definitely something we need to address. But I'm not sure whether, I think the whole profile is getting so complicated right now. My question is, okay, so today we don't have these management, so all the stuff is in adapter. So if we implemented the profile, does it mean that we simplify the adapter level on the OOT and ONT side? Or just, I think probably it is true that today's adapter may not addressing all these issues. We're just using the default. So then definitely we need a mean to make it more adaptable in some way. So that is my initial. I know we've been talking about for a long time now, since April, about the March timeframe, but so far what am I going to say? What does it mean once we introduce the technology profile? What's the impact to the existing adapters? So I do need to understand those.
I think maybe the distinction here is there might be some elements of the technology profile that need to be exposed as far northbound as OSS. Things like ONU types, like if a particular ONU is an all-in-one or has multiple physical ports for multiple customers, or multicast capabilities, some of that, has to kind of get promoted out, if you will. But things like ONU ID ranges, ALEC ID ranges, typically we want to keep that within the complex or within VOLTA itself, because we don't want to confuse people with what ONU ID means internally versus what ONU ID may mean externally for it all. So it may be just a subset of the full profile is what gets exposed north, but internally, I mean, we've got to keep track of some of this stuff someplace. In terms of the adapters, I know I had to make a lot of assumptions with the current adapter just because I have nothing else informing me how to build the service. So I pick one GEM port, I pick one TCONS, I pick one UniPort and set up unicast and go. But if somebody northbound wanted to build a service around 3 GEM ports, one of them being multicast, and then an ONU with multiple physical ports for multiple customers, they have to see those elements.
Yeah. So I mean, those things could be part of the profile if we wanted to do that.
And maybe it's more of a question of how much of a profile is exposed northbound. Maybe it's inclusive to include everything we need, but then maybe when we talk through SIBA or northbound or to whatever, we just expose maybe just a subset of things that are relevant and configurable by OSS.
Right. For instance, multicast. I mean, we don't really care externally what the GEM port, multicast GEM port is, but the fact that it's there needs to be configured.
Right. Yeah, we just need to know that it can do it, not so much how many GEM ports it has that are capable of multicast, or it's something like that.
I have a question, and most of it is maybe because I've not followed the profile discussion for a long time. Is there some place where some kind of flows that shows the end-to-end how the profile will work, and for instance, how the profile will get into the TV store, for instance? Is there such a place where I can go and look at the end-to-end flows of the profiles?
Endpoint flows. So, there's a document associated with the technology profile epic that describes what the open flow definition of the flows would be and how they're converted into the real gem alloc ID configuration of the particular flow.
Yeah, thanks. So what actually meant is more like a sequence flow of events from end to end, like from a northbound all the way to the adapters and the devices. How profile will flow in the system.
Maybe.
We have not worked through the SIBA workflows yet to see how they get pushed from upstream. That's something that's still on the plate to do through SIBA.
Okay, because it will be very helpful in it, like Shad was mentioning about the gRPC interfaces. Knowing those flows, those sequences of events, will determine what actually need to exist in the core in the northbound side, and if there's a way to make things simpler by going gRPC, or should there be?
Well, I mean, for sure, the interface northbound. Well, okay, no, not for sure. Never mind. I'm gonna take that back.
So the way that we create profiles right now is defined on the wiki page under creating technology profiles, if that's what you mean.
So Ken, taking the example, I think there's one kind of a mini profile implemented already. It's called the resource profile, and that's just from the CLI. CLI pushes a JSON blob. That's from what I recall, into the KV store. And into in a key location that the VOLTHA core also knows about. So that's how it is right now. So it's not gRPC, but it's something getting into the KV store directly. Right now it's a CLI pushing it, and the adapter, not the VOLTHA core, but the adapter, OpenVolt adapter. Looking up the key, and if it finds a resource profile over there, using that. So that's how that's all we have right now as an example.
Okay, so is that the plan for in production, to do things via the CLI and directly into the KV store, or and how big are these profiles?
In terms of bytes?
Yeah.
They're not particularly big. I mean, there's an example on the wiki as well. It shows what exactly the profile is, or actually I think I might have so I mean we have to somehow convert this into a byte count, but so here's an example of what a profile looks like.
Okay, so they're not that big, so they could go via that via gRPC interface if we want to.
So yeah, so the only scalability issue is that we're using part of the flow table ID range, which where we're kind of using 64 to 255, and that should be plenty, because typically a subscriber, I mean an operator would have one profile that defines most of their services, and maybe they have just a handful of all the different types of services they have, but the idea is that it wouldn't be large for any given operator.
Okay. So what's the plan in production to push those data down?
Yeah, so some OSS system or some system that manages what services would basically create these and push them down to VOLTHA. Okay, so it will be via gRPC, or will it be directly into the KV store? The thought was it would be directly into the KV store. But depending on the needs, we can modify that.
That's a little this thing. I mean, exposing the KV store northbound is probably not a good thing.
Yeah, I don't.
Well, no. At this point, I think it depends on. I mean, at this point, the vision of that is the northbound is SIBA. So there's no OSS that's going to come down directly into the KV store of VOLTA and be putting stuff. I mean, right now, the interface, we're expecting SIBA to be providing a northbound. I mean, if you want to get into the AT&T workflow, we're expecting SIBA to provide a northbound interface to OSAM. So OSAM is going to talk to SIBA in order to push down technology profiles. And SIBA would be the one that would be
I think this is
making
more
them
of a
available to VOLTA.
clean interfaces, even within the pod. I think most everything else that interacts with the KV store goes through a VOLTA API layer, and continuing to keep it that way enforces some, some good clean interfaces, even between SIBA and VOLTA or anything else northbound.
Yeah, absolutely. Yeah.
Yeah, and then I don't think it's that big.
No, yeah,
the gRPC layer north of VOLTA exposed this as an API, and it may mean like a one-to-one translation, or it could do some cleanup or screening of data, if you will,
validation,
or whatever. But I do think keeping etcd and VOLTA's etcd data to VOLTA is a good idea.
Yes.
Yeah.
No, I
we may even change the KV store. So it's
One question.
Yeah, I mean, SIBA should be calling the proper APIs that VOLTA uses to expose this information. So yeah.
Yeah,
so I'm just saying that it's not coming from super high northbound. I mean, it's coming from one step northbound. And at this point, the way we've envisioned it is that we're not wanting necessarily the steps along the way to get into a lot of decoding of whatever's in that. So I think someone said earlier, a blob of JSON. I mean, that's really we're kind of expecting an operations team somewhere to create a blob of JSON that defines the profile parameters, and that blob just gets pushed down as far down as it goes, and not do a lot of processing of that blob along the way. So I mean, it's not like even for AT&T case, the workflow cases, it's not about everybody knowing what every single parameter is. It's more about an operations team creating the profile that does the things that operationally needs to be done in AT&T's network, and then that blob of stuff comes down and kind of just gets passed on through to wherever it needs to end up.
Sean, when is this some of these profiles being engaged? I would say that the OpenFlow, the ID table, that only define the technology profile, right? So is that the ONU stuff is being engaged when the ONU is built, or and the OOT interface is when the OOT is built? I think that may be related to Ken's question, right? So all these profiles, when will those profiles be engaged or be retrieved and then and to be take effect?
So
we're not talking about using the OpenFlow messages to capture all these, right?
No, obviously not. No. The OpenFlow uses the table ID to reference the current technology profile, right? So that's the relationship between a flow and its associated technology profile for the technology specific aspects of the flow, right? So I think that when you came along and you created an OLT, you pre-provisioned an OLT, it would reference the equipment profile. When you discover an ONU, then it would go and use the the vendor ID and the ONU type to go and get the appropriate profile for that.
Go get it from where?
The KV store or the database or wherever it's stored.
So basically, those part of those profile will be part, of course, even with the technology profile, will be part of the VOLTA turn-up lifecycle.
Yeah. So if there isn't a profile there, then either you use some predefined defaults for how you want to treat the equipment, or you use some defined entry in that database to fall back to.
Yeah, I think back to Ken's question, maybe a very simple sequence diagram of just a life cycle events of, okay, I brought on my OLT and I'm bringing on my first ONU, and let's say they have 3 services, kind of the basic interaction, just to kind of get an idea of where the touch points would be. And then we can decide, from there, whether the API layer should be stronger or weaker, depending on, who's talking to who.
Well, I think currently we don't really have much of a definition of or I haven't seen anyway, the definition of the interface between VOLTHA and the NEM layer, right? I mean, so in terms of capabilities that we're going to be exposing and managing in VOLTHA, the technology profiles would be one of those. So just to look at the layer above VOLTHA, right? So there needs to be right now it's defined, so I can go and add my technology profile directly into the KB store. So in a deployment scenario, I think as brought up, there has to be that a better defined interface between VOLTHA and northbound, right, from a management perspective. So the profiles themselves would be, again, the idea being blobs of JSON that could be just passed down to be stored in the database or KV store of VOLTHA, right? Transparently referenced via the flow table ID for actual flows themselves, or referenced by the creation of a type of equipment in the case of these additional types of flows. So I think once there needs to be a story to define that those interfaces northbound, and I guess we need to document better the interfaces between the ONU adapter and the OLT adapter into the KB store. I mean there are there's some definition of what that should be. I don't think it's being put together with a message sequence diagram. So I guess I could do some work on that, both for the OpenFlow table ID profile access and a potential equipment access. If people think that's worthwhile going for, I mean, there's no point doing that work if no one wants to use that particular type of profile.
Well, I mean, I guess maybe the point is not so much to say this is the way it's going to be, but at least maybe just a high level thought of how it gets in. I suspect it'll need to be gone back and forth, and we'll have to kind of see how it goes. So yeah, I guess I'm not saying we need it to move forward, but kind of a relative positioning of who's doing what at maybe a very basic level. Like somebody comes along and says adds flows for specific services. All right, I see. Right now, for example, OLT app has add subscriber, very simple, that says I'm going to double tag a port and we have unicast traffic. And maybe it might be something north of there that says now we have more types of services to add, or we have different APIs that are exposed northbound to reflect these services, or some generalization of those services. Yeah, I'm just thinking out loud, trying to think of where it would fit, whether or not it's
so
in the KB store or not.
Yeah. So there's discussion of that, and there's some stories around basically supporting adding the flow ID to the subscriber record for referencing the technology profile, and also the bandwidth profiles or the speed profiles for the service for that particular subscriber. So there's some stories for that are kind of in flight right now. So I mean there is work going on for technology profiles. Some of it can't be merged right now because of the lockout for 1.5, but there's work in progress for that. And there is a lot of documentation around that that's within the EPIC as well.
Okay. We may need a lockdown for this, combined with the CIVA community. Okay. I think, Julie, do we come to a point? Well, we usually take back the meeting, right?
I think so. I don't know that we can make any more progress on this call today. We've got about 8 minutes left. So I think we have some follow-up discussion. I'm hoping that some of that can continue over VOLTHA Discuss, especially now that Sean has given a walkthrough of the document that he'd provided for review. So, and we may need, I think we'll probably need to schedule a follow-up for one of these Thursday calls as well, when we can have some more discussion time. Or if we need to have a separate meeting, we may need to do that instead in a different time slot. So let's see how we can progress over VOLTHA Discuss to continue exchanging thoughts on the path forward here. Sean Missette, any specific items you want me to note at the moment?
Yeah, I don't think so. I mean,
okay.
Just leave it as is, I guess.
Okay.
Thank you, Sean. This is good. I appreciate it.
You saw that.
Okay. And I think hopefully everyone is seeing my screen. I did navigate over to the Tech Profile Epic. So we're not really going to have a lot of time for planning today for Sprint 9, which kicks off next week. As Sean mentioned, we do have the code freeze right now in place for anything related to the Tech Profile work. And I did see an email from Saurav on VOLTHA Discuss that he expects that to be lifted early next week. So we will continue to wait for notification. And then I think some of that work will hopefully get resolved early next week. So in terms of Sprint 9, let me take a quick, which screen am I looking at? Okay, we'll go over to the release planning slides because I don't think we'll have a lot of time to look at anything in the backlog or so on. So a couple items that we had, this was what we had for the target scope when we had our lockdown. And I've had this updated for a few weeks. I'm hoping I can remove this now to save space. Any objections from the team? Do you need that there still for tracking for visibility? Okay, hearing nothing, I'm going to just clean that up so we can get everything on one screen. One item I also wanted to talk about was the ONOS apps and HA. We had that flagged as an item for 2.0. If I look at CIBA 149, update ONOS apps to work in a cluster mode. I think what we had planned to have for 2.0 is covered by CIBA. So I wanted to check with the group if that is your view as well. If so, then I think this is kind of removed from our list and really is covered by CIBA.
Right.
How is that working since CIBA has not moved on to 2.0 yet? And currently the current CIBA plan is not to do this, not to make those apps HA for the current version of CIBA. And so are you saying you're putting a task on them that whenever they move to 2.0, they need to do this, it's required, or
so
how is that happening?
This is mapped over to the December milestone, which roughly aligns with the planned 2.0.
But they moved it to low though.
Oh, did I not update?
I think Matt, if you want to comment,
okay.
At least for
this makes the distinction of if I'm running 3 ONOSes and I need, basically to the second or less recoverability versus I'm running 1 ONOS and Kubernetes will recover within, maybe 5 to 10 minutes, or not even that, maybe even less. What's good enough for now? What's good enough for December? And then from there, we can move on to actually running 3 instances of everything and truly being HA. So it's really HA, in terms of zero downtime versus HA in terms of I can be down for 10 to 15, 20, 30 seconds, down in terms of provisioning, and what's acceptable based on resources and what we can do in the time frame.
Correct. So basically, based on the scale and then the impact, we think we can defer this one. So it's not like they are not going to fix it, but it's not in the December timeframe, so it will not meet the 2.0 timeframe, Julie. So we did defer that.
Okay.
And it is ONO's requirement, right? So.
I mean, actually, for ONOS, it's probably a bit easier since ONOS is already HA capable. We just haven't tried it in this context. Whether the apps or not, I don't know. But I'm more thinking of it kind of holistically, like multiple V cores, multiple OF agents, back to Sergio's design. You know, all of it together needs to be there, or it's kind of like, well, if I've got one side that does and the other side that doesn't, then, you know, who am I kidding? I don't have HA for any of it.
But yeah, I think the apps HA strategy, I think the ONOS community need to address that. I think that as far as I know, the ONOS app is not, you know, it itself doesn't have the HA capability. I think there's some framework need to discuss. So that's definitely not something we can address in 2 months. So defer.
Okay. And we've got about 2 minutes left. So in terms of scalability, Sean Ying, I think we had an action item that post BBWF, we were going to try and have the scalability requests or targets clarified. You were collecting some feedback from operators. So we still have a little bit of time before this is going to be pulled in. A reminder that our next development sprint, Sprint 9, is our last one before we go. Let me go to the sprint schedule, the last development sprint that we have planned. And then it does call into question the timing for the containerization work for adapters as well, because the assumption we had for Sprint 10, I've got 1 minute left, is that the containerized adapters, that this work would be completed by the end of Sprint 9. So we're not going to have time to have the discussion today because we are out of time for today's meeting. But if you have comments you'd like to post on VOLTHA Discuss in terms of this, please feel free to do so. But I think we need to really look closely at what's achievable in Sprint 9 and then figure out our path forward. So we'll probably need to continue some discussion on the sprint planning on Tuesday's call. We only have an hour and we have some additional part of the time for additional presentation as well. So I think I'll ask, since we don't have time on today's call, for the leads for different technical scope items, you know, as usual, just pull in the appropriate work with the sequence you're working through with your sub-team on getting items pulled into Sprint 9. We have the placeholder there and we have a few items mapped over already. And I'm out of time, so let me just quickly, I'll go over to the backlog so you can see Sprint 9, and then we'll wrap up for today, and then, you know, continue discussion over VOLTHA Discuss if needed. And let me see if I can scroll down to Sprint 9. Here we go. Okay, so here you see Sprint 9 on the screen. We're getting a few of the items pulled in, some of the core work, for example, and a few items. And there's also some tech profile work that I know Craig is going to be working on, and it's currently shown as a subtask, so it's not mapped into the sprint, but that will be updated soon. Any last comments or questions before we drop today?
Just a question, how many people are going to the BBWF?
I am. That's one.
So Sean, you are going?
Yeah.
Was it Sean?
Yeah.
Okay. Okay,
Right.
great. Thanks.
Okay, thanks, Sean. And then a reminder, on Tuesday, we have the OpenOLT adapter, the branching proposal or the support proposal for 1.5 and beyond in 2.0, and that will be given by Shad. And then we'll continue work on kicking off Sprint 9. And with that, I'm going to stop the recording for today and close our meeting. Thanks, everyone.